Hi, and welcome to the Math Essentials podcasts. This is dealing with section 1.2 in the Mathworks 12 textbook, which is entitled The Equation of a Line. So part 1 is going to deal with direct linear relations in the equation to solve direct linear equation or direct linear relation questions. And so there is an equation that we can use to solve direct linear relations, and we do this because sometimes information may not be given accurately. So if we were to always go by a graph, we're really just estimating our amounts unless it falls on a certain point. And so we can express the line of a direct linear relation in terms of an equation. We can use that equation to solve for any point on that line. So the equation that we're going to use for a direct linear relation is as follows. So y equals m and x. Now y in this case, remember, is equal to a dependent variable. X represents an independent variable. And m is, of course, our slope. So once we've established a linear relation, we can calculate the slope of that linear relation, and we can really set up an equation by which we can measure that or any point in that. So for example, I've got here a really good example on measurements. So oftentimes when we deal with government codes in buildings, a lot of times sometimes codes are written in what we call SI units, and the SI units in Canada are metric. Okay, so if we wanted to convert, and of course most of our boards and most of our tools are still in the imperial system, and so we need an easy way to convert. Now we can set up, because we know this to be a direct linear relation, as I increase or as I change the feet, I'm also going to change the meters in some sort of a linear fashion. So I can set up equations in which to solve any sort of conversion problems. So that's what this table sort of does in your book. And so if we wanted to do that, to set up an equation, say from feet to meters, we can do that by y being equal to, so feet being equal to 0.3048 times meters. Okay, and so our slope is going to be that relationship, so this value is m. And our units of rate of change, well, that's feet per meter, right? So feet per meter. So what does that mean? That means that really there is about 0.3 feet or 30 feet per meter. Okay, so that's a quick way to do it. And we're going to look at an example. Right now, this one is out of the textbook. And so this is dealing with air temperature and elevation. And one of the things to notice, if we look at the table, it looks like our elevation is increasing. So as we increase elevation above sea level, but our temperature is decreasing. And so our independent variable here is going to be this, because we can change that. We can change our elevation above sea level. And when we change the elevation, we know that the air temperature changes, so it's dependent upon the elevation above sea level. So that's our y. Now, when we come to sort of a problem where we can try to solve, we have to remember that on a graph, because we're going down, because we're hitting negative values and increasing negative values, that our graph is going to slope this way. So when we actually calculate this out, we find that we have a linear relation. It goes through the origin. right, which makes it a direct linear relation, and it's got a negative slope. Okay, so this right here is a negative slope. Okay, so now we can look at the formula for finding this particular value. So to do that, we need to find the slope of this line. So the slope of this line is equal to, remember, the change in y over the change in x. So picking 2 points, and maybe I'll stick with the textbook and I'll pick this point here. The change in y, right? So this is my y, this is my x. So the change in y goes from 0 to -1. So that's -1. The change in x goes from 0 to 100, and that's 100. Now, -1 divided by 100, when you calculate it out, is equal to a -0.01 degrees Celsius. So what does that mean? That means for every meter that we change our elevation, so if for every meter we increase our elevation, we go down 0.01 degrees Celsius. Okay, which doesn't sound like a lot. From that, we can calculate our equation. So remember, our equation is going to be y, right? So whatever, to find the temperature, it's equal to our slope, right, which is 0.01 times x. Okay, and so that's our equation for our line. Now, to actually apply that, we can solve for different sorts of problems. And that's what the next sort of part here is going to do. We're going to solve different things. So for example, if I had 239 meters, using my equation, using my line, it would be very hard. But using my equation, well, that's very easy. So 239 meters, if I look at it, if I apply my formula, y equals 0.01, right, times x, right? So 239 meters is my x. So to solve for degrees Celsius, I take 0.01 and I times it by 239. Okay, when I do that, I'm left with a -2.39 degrees Celsius. So that's a very easy way that I can calculate what my temperature will be at different elevations. Okay. Now, if I was given the temperature and I was to ask, well, what elevation would this temperature exist? I can do the same thing. So applying the same formula. But now I've got the y value. So -3.7, right, degrees is equal to -0.01 times by x. So now to solve for x, right, I divide this by -0.01, divide this by -0.01, these cancel, and my x value is equal to, when I take 3.7 divided by 0.01, I should end up with 370 meters. Okay, the next part is going to deal with partial linear equations.